Hello, Renan students. This time, let us discuss the conditions for parallelograms. Let us first have a warm up. Justify each statement. For number one, QR is congruent to QR. That's what we call the reflexive property of congruence. How about L is parallel to M? Converse of alternate interior angles theorem. Now let's evaluate each expression for x plus 12 and y plus 8.5. So number 3 to x plus 7, substitute x by 12. 24 plus 7 is 31. How about 16x minus 9? 16 times 12 minus 9. So that's equal to 183. 8y plus 5. That means 8.5 times 8 plus 5 is equal to what? 73 degrees. Okay, so the objective for this lesson, prove that a given quadrilateral is a parallelogram. So last time you have learned to identify the properties of a parallelogram. Now you will be given the properties of a quadrilateral and will have to tell if the quadrilateral is a parallelogram. To do this, you can use the definition of a parallelogram or the conditions below. So these are the conditions for parallelograms. Theorem 6-3-1. If one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. So, next, Theorem 6-3-2. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And next, Theorem 6-3-3. If both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. Okay? So these are the conditions for parallelograms. Now, the two theorems below can also be used to show that a given quadrilateral is parallelogram. For Theorem 6-3-4, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. And Theorem 6-3-5, if the diagonals of quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay, verifying figures are parallelograms. Now, show that JKLM is a parallelogram for A equals 3 and B equals 9. Okay, let us substitute the values of, the lengths of KL, LM, JM, and KJ. Substitute natin yung dito sa KJ. 15 times A or 15 times 3. 45 minus 11. Alam yun. 45 minus 11 is 34. Dapat LM is also 34. 10 times 3, 30. 30 plus 4, 34. Tama. JK is congruent to LM. How about this? KL. 45 plus 6, 51. 72 minus 21. Yan din. So, I think it's a parallelogram. JK is 34. LM is also 34. Because yung natin kanina. Orally, 51. Okay. Since two pairs of parallel sides are congruent, therefore JKLM is a parallelogram by Theorem 6-3-2. How about this? Quadrilateral QRSP or QPSR. Is it a parallelogram? Let us show for x equals 10 and y equals 6.5. Okay. Angles are given. What's the measure of angle Q? 6y plus 7. Angle S, x 8y minus 6. Angle R, 15x minus 16. So since angle Q and angle S are opposite angles, they are congruent. So pick lang natin 8y minus 6y, 2y. Tapos 7 plus 6, 13. Wait. Meron pala dyan 6y. Y is 6.5, so mga 13 halves. So let's try to solve for angle Q first. 6 times 6.5 is 6 times 6.5 plus 7 is 46 degrees. Angle S dapat 46 din. 8 times 6.5 minus 6 is also 46 degrees. So, excuse me. So we have shown that the opposite angles in quadrilateral QRSP are congruent. They have they each have a measure of 46 degrees. Now angle R is 15x minus 16. So if x is 10, 150 minus 16 is equal to 134 degrees. Now if we're going to add 134 and 46 is equal to 180, dapat supplementary kasi consecutive angles in quadrilateral or in a parallelogram are supplementary. 134 plus 46, correct, is equal to 180 degrees. Therefore, PQRS is a parallelogram. Yes, PQRS is a parallelogram by theorem 6-3-1. Next, show that PQRS is a parallelogram for A is equal to 2.4 and B is equal to 9. Okay, so here, dapat QP and RS are congruent, and angle Q and angle R should be supplementary. Okay, let's substitute the value of A. 7 times 2.4 is equal to 2. 2 times 2.4 plus 12. Let's see. PQ is congruent to RS. They are both equal to 16.8. Yes, by substituting the value of A with 2.4. So PQ is, so they are equal, therefore PQ is congruent to segment RS. Angle Q is 74 degrees. How did you get that? Substitute. 10 times, okay, 90 minus 16, 74. Or 81 plus 25. 81 plus 25 is 106 degrees. Now if we're going to add, yes, the sum is 108 degrees. Therefore, angle Q and angle R are supplementary. And in the first place, they are consecutive angles, so they are supplementary. So PQRS is a parallelogram. That's the answer. So one pair of opposite sides of PQRS are parallel and congruent. And by theorem 6-3-1, PQRS is a parallelogram. Excuse me. Okay, determining the quadrilateral must be a parallelogram. Justify your answer. Yes, a 73-degree angle is supplementary to both its corresponding angles. Or yes, or consecutive angles. By theorem 6-2-4, the quadrilateral is a parallelogram. Determine if the quadrilateral must be a parallelogram. Justify your answer. No, one pair of opposite angles are congruent. The other pair is not. The conditions for a parallelogram are not clear. But two pairs. Pag isang pair lang ang pair of opposite angles ang congruent lang, we're not sure if these are congruent. Halimbawa, 120 yan. Tapos di naman pala equal yan. So, no. Now, determine if the quadrilateral must be a parallelogram. Justify your answer. Yes. The diagonal of the quadrilateral forms two triangles. And two angles of one triangle are congruent to two angles of the other triangle. So the third pair of angles are congruent by the third angles shown. So both pairs of opposite angles of the quadrilateral are congruent. By theorem 6-3-2, the quadrilateral is a parallelogram. Determine if each quadrilateral must be a parallelogram. Justify your answer. No, because two pairs of consecutive sides are congruent. So dapat pag parallelogram opposite, not consecutive sides. Opposite sides must be congruent, not consecutive sides. Kahit na yan, which will be our future lesson. None of the sets of conditions for parallelogram are met. Helpful hint: to say that the quadrilateral is a parallelogram by definition, you must show that both pairs of opposite sides are parallel. Now, show that quadrilateral JKLM is parallelogram by using the definition of parallelogram J -1 6, K -4 1, L 4 5 M 7 0. So let us plot these points in the Cartesian plane, and let us find the slopes of the opposite sides. Okay, so this is a parallelogram. Opposite sides are parallel. Pag parallel sila, they have equal slopes. So, what is the slope of JK? Negative 5/3. What's the slope of LM? Negative 5/3 also. So that means JK and LM are parallel lines. About JM, 3/4. About KL, 3/4 also. So JM is parallel to KL. So that means there are two pairs of parallel sides in a quadrilateral. So this is a parallelogram. Since both pairs of opposite sides are parallel, JKLM is parallelogram by definition. Show that quadrilateral ABCD is parallelogram by using theorem 6-3-1. A23B62C50 D11. Find the slopes and lengths of one pair of opposite sides. Slope of AB, negative 1/4. Slope of CD, negative 1/4. They are parallel. Square root of the length of AB by distance formula. Square root of 17. Getting the length of CD by the distance formula, square root of 17. So AB and CD have the same slope. So AB is parallel to CD, segment AB is parallel to segment CD. Since AB is equal to CD, AB is congruent segment CD. Here by distance formula. So by theorem 6-1, ABCD is a parallelogram. Use the definition of parallelogram to show that the quadrilateral with vertices K negative 30, L negative 7, M 35, and M is parallelogram. What is first of the slope of KL, negative 7/2, slope of MS, negative 7/2, they are parallel. Slope of LM, negative 1/4, slope of NK, negative 1/4. So two pairs of sides are parallel. So it is a parallelogram. Yes, by definition. KLM is a parallel. Two pairs of opposite sides have the same slope. So KL is parallel to MM, LM is parallel to NK. So you have learned several ways to determine whether quadrilateral is parallelogram. You can use the given information about the figure to decide which condition is best applied. So, summarize, we have here the conditions for parallelograms. Both pairs of opposite sides are parallel. One pair of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. One angle supplementary to these consecutive angles, and the diagonals bisect each other. For here to show that the quadrilateral is parallelogram, we only have to show that it satisfies one of these sets of conditions. Application: the leg of a keyboard tray are connected by both of their midpoints, which allows the tray to be raised or lowered. Why is PQRS always a parallelogram? PQRS, why it's always a parallelogram? Now, since the bolt is at the midpoint of both legs, that means PE is equal to ER and S is equal to EQ. So the diagonals of PQRS bisect each other, and by the theorem 6-3-5, PQRS is always a parallelogram. The frame is attached to the tripod at points A and B, such that AB is equal to RS and BR is equal to SA. So ABRS is also a parallelogram. How does this ensure that the angle of the binocular stays the same? Now, since ABRS is parallelogram, it's understood that AB is parallel to RS. Since AB stays vertical, RS also remains vertical no matter how the frame is adjusted. Therefore, the viewing angle never changes. So for quiz part 1, show that JKLM is a parallelogram. For A equals 4, B equals 5. Okay, and I think we can do it. The theorem, diagonals bisect each other in a parallelogram. So this is now the answer. JN and M is equal to 32, KN is equal to M is equal to 10. So JKM is parallelogram by theorem 6-5. Okay, show your solution. Send it. Message it. Determine if number 2. QWRT must be parallelogram. Justify this your answer. No, because one pair of consecutive angles are congruent and one pair of opposite sides are parallel. The conditions for a parallelogram. 3. Show that the quadrilateral with vertices E negative 1, 5, F 2, 4, 6, G 0, negative 3, and H negative 3, negative 2 is parallelogram. Okay, use of graphing paper. Finding the slopes of EF and GH, they are both equal to negative 1/3. So They are parallel. And finding the lengths of these opposite sides, EF and GH, they're both equal to square root of 10, so equal sila. So since one pair of opposite sides are parallel, EFGH is parallelogram by theorem 6-3-1. End of slideshow. Thank you very much for listening. I'm your Sir Ken. Goodbye.